Your sensors could be telling you far more than just on or off. Most of them already have the brains to do it. They sit there reporting a single bit or one analog value, while everything else they know stays locked inside. iolink is the standard that unlocks it. It turns a plain sensor into a smart device that reports its real reading, its settings, its diagnostics, and even its own identity. And it does all of that over the same cheap 3-wire cable you already run. So what is iolink, and why is it spreading so fast? Let me show you. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC networking and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the sensor. Let's define it cleanly. iolink is point-to-point digital communication, down to a single sensor or actuator. And here's the part people miss. It runs over a standard unshielded 3-wire cable, the exact cable you already use for an ordinary discrete sensor. No special wiring, no fancy connector. The big distinction is this. iolink is not a fieldbus. There is no shared bus, no device addressing, no daisy chain. It is just one master port talking to one device, digitally. That single digital link is the whole idea, and everything good about iolink comes from it. So what does that buy you over the wiring you already know? Start with the old way. A discrete sensor gives you one bit, on or off, nothing else. An analog sensor gives you a single value, 4 to 20 milliamps. You still have to scale it, and noise can corrupt it on a long run. Both are thin. iolink sends 4 things instead, all down that one cable. First, the process value as clean digital data. No scaling, no drift. Second, the parameters, so you can read and change the device settings. Third, live diagnostics, like a contamination or temperature warning. And fourth, identity, the vendor and exact part number. The sensor stops being a dumb contact and starts being a device you can actually talk to. Now, how it connects. The picture is simple and worth getting right. At the bottom is the iolink device, your smart sensor or actuator. It plugs into an iolink master. The master is the hub. It has several ports, one device per port. It gathers all of them together. Then the master connects upward to the PLC, but not over iolink. It connects over a real fieldbus or industrial Ethernet, Profinet, Ethernet IP, Modbus, whatever the plant uses. So iolink handles the last few meters to each device, and the fieldbus handles the rest. I have a separate video breaking down those industrial networks, link below. Here is where iolink earns its place. 3 features. First, remote configuration. You set a sensor's switch points from the control room instead of climbing a ladder to a machine. Second, live diagnostics. The master sees a sensor fouling or drifting and warns you before it stops the line. Third, and this is the big one, automatic device replacement. When a sensor dies, you pull it and plug in a blank new one. The master recognizes it and reflashes the saved parameters automatically. No laptop, no manual setup, no scanning mistakes. A maintenance tech with no programming swaps a sensor in a minute. That alone is why iolink keeps showing up on new builds. So here's what to walk away with. iolink is a point-to-point digital link to a single smart sensor over an ordinary 3-wire cable. It is not a fieldbus. It adds the process value, the parameters, the diagnostics, and the identity all over that one cable. The device talks to a master, and the master talks to the PLC over a real network. An automatic device replacement makes a swap effortless. Get that, and every smart sensor on the floor stops being a black box. Now, go make it concrete. If you want to practice PLC networking hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe, new video every Tuesday. See you in the next one.